Joel and I have the pleasure of working at MIT Lincoln Laboratory Beaverworks. Beaverworks is a joint center between MIT and Lincoln Laboratory that brings real-world projects to college students to solve and challenge them. Beaverworks Summer Institute was created in the same hands-on project-based approach so we could bring it to high school students. Students that we saw entering college without the skills required in today's careers. We take the model of project-based courses like MIT and use the same model for high school. We take curriculum developed by researchers, engineers, scientists, and use it to provide opportunities to high school students to learn skills like Python, to develop and build own machine learning algorithms, and then understand strengths and weaknesses in AI technologies. So in one sense, this is a chance to work with people who will write future textbook, creating the curriculum now. Next slide.
Okay, I'm sorry, Lisa, I've got to start sharing, I think. So, right? You guys aren't seeing the slides?
Yep.
Sorry, that was a good overview.
There was nothing on that slide, so.
Here we go.
All right. So what is Beaverworks Summer Institute? It's an intense 4-week program for rising high school seniors. Our director, Bob Shin, was challenged in 2015 to create something that will fill in the gap for high school students, a project-based STEM curriculum that helped students learn basis of autonomous systems. Autonomous systems include all the self-driving cars, drones, marine vehicles that are being created. Also using technology that provides safety features like collision alerts, even while the technology is being worked on for fully self-driving vehicles. Science and engineers are creating the contents for the courses, and then they become our instructors for our summer program. They get to share what excites them about their research with you students. And then we use final competitions and capstone projects to challenge and motivate students to do more. And then they go beyond what we think is possible, what they think is possible, and then they succeed. Next. So in 2016, this all began as an experiment. Could we teach these college level courses in autonomous systems to high school students? And the resounding answer was yes. It was a course taught by Dr. Sartosh Carmine to graduate students at MIT. Lincoln Laboratory staff created the framework that we continue to use today. So MIT and Lincoln Laboratory essentially created a computer on wheels. This computer on wheels has sensors and challenges for the students to complete. All of the things needed to make these cars self-driving. Students learn how to load the software, build and train machine learning algorithms, teach the computer to use cameras to recognize signs and objects. They interpret depth data from the stereo cameras, use LiDARs to stay within tracks. Intentionally, it's too difficult for a single student to do in 4 weeks. But as a team, the students learned how to work together and accomplish even more. In 2016, we started with just 46 students, and you can see in the video what they accomplished. Those cars are navigating the course all on their own. The students following are only holding down the safety switch in case the car goes rogue. Think about it. The model cars are navigating the course using software that high school students like you wrote and tested. Next slide. So in the years that followed, we were able to add even more courses. In 2017, we had 3 courses and 98 students. In 2018, 7 courses and 198 students. And then in 2019, we added 2 more courses, bringing the total till 10. Our director, Bob, doesn't do anything small. As you can see, he likes us to keep doubling every year. So 10 students in 2019 allowed us to have 263 students. These new courses stepped away from autonomous vehicles to create more human-focused design, remote sensing for disaster response, where the focus is to learn how to respond to a disaster, how data analysis can help, and how we can improve the ways we respond. To designing assistive technology, where the teams work with one person to understand their needs, and then they design, test, implement a solution with a very traditional engineering approach to help their client as co-designers. And this year, we also piloted the autonomous race car course for middle school students from the Boston area. The curriculum was modified that students without any programming experience could attend and learn to create a self-driving model car. We also had a less expensive model and sensors with goal of democratizing the curriculum so that we can make it more widely available. We are still achieving the same goals. So the car you saw in the previous slide can cost to $8,000 to $10,000. The car we were able to create for the middle school course is $1,000. So more achievable for us to send out. Next slide. So like many programs, 2020 and COVID happened. So we had to quickly in March figure out how to switch to be virtual or not run at all, which wasn't the option that we were going to do. So we figured out the logistics to ship project kits to most of our students, as well as how we can host a virtual final event. And while doing that, we were still able to add a new course, Serious Game Design with AI. An active area of research is creating serious games, AKA simulations of real-world events, and use both humans and algorithms to play out a predefined goal. Students had to work together to program their modules to work within the game framework, and then test to see how their modifications affected other teams' modification in the final event. Given the significance of COVID and the research that was going on with private automatic contact tracing at MIT, Lincoln Labs, Mass General Hospital, with interest from Apple and Google, we created a Pi-Pact independent project. Students were given Raspberry Pi kits in the basics of technology and challenged to research the RF technologies, data analysis, and algorithms behind automatic contact tracing. In reality, they were challenged to develop a hypothesis, collect the data to test, and be able to communicate their results in a scientific paper format. Many students then went on to use their results in science fairs and competitions. Next slide. So in 2021, due to the pandemic, we still had to remain virtual. Having more time than we did in 2022, in 2020, we were able to increase from 7 courses to 13 with an additional 2 in-person race car courses. Then we were able to host another successful virtual event in which we had over 8,000 people viewing. We added the below courses that were previously not virtual: assistive technology, autonomous air vehicle racing, unmanned systems, synthetic aperture radar, and brand new to BWSI for 2021 were the autonomous underwater vehicle challenge, cybersecurity for software intensive systems, and quantum software. So our instructors and staff were very busy getting virtual and adding these new courses. Next slide. Oh, and now I'm going to turn it over to Joel.
Yes, thank you. I think this is giving you a great kind of overview of the number and the diversity of courses that Lisa, that the program has. It's really great to see the diversity of courses and the different mission areas, really. But what I want to talk to you a little bit now is about the CogWorks course. The Cognitive Technologies course was created by Dr. Ryan Soklasky, who works at Lincoln Laboratory. And while he couldn't be here today, I'm hoping that I can give you a little bit deeper view about what CogWorks is and why it should be interesting. And we'll see where we go with that. So cognitive technologies really are a lot of things to do with artificial intelligence and machine learning, right? We all know applications like Shazam, which recognize the song and names it. We also everybody uses autofill now and autocorrect. Autofill in particular, most of us are talking to Siri every day. And how does that technology work? For most of us, it's a black box. But I'll get back to that that concept of that black box and how we want to blow open that black box, right? Photo identification. I mean, I'm sure many of you have used either iPhoto or Google Picture Match or anything like that in order to find similar pictures or use a program to identify objects. The fact that there are applications out there that you can take a picture of a flower and the application will tell you what kind of flower that is, right? That's all machine learning and cognitive technologies behind that. So the objectives of the course is really to use that project-based learning that's been so strong in the theme of the Beaverworks Summer Institute to kind of immerse students into that those applications, right? Which are, there's a lot of math, there's data science, machine learning, all go into making things like this work. Right. And so the students have to first learn how to generate those algorithms and then develop that software from scratch in Python to first solve kind of preset problems. And then they expand to select their own problems to solve with these technologies. So I think I mentioned how the black box, right? One of the primary things that Dr. Siklasky said about was to have no black boxes when you're building this software, right? If you're going to use some canned software, you need to build it from scratch or understand what it's doing so that you really can rely on the results. And I'll talk about ethics in a couple of slides here. But this really is the part of learning how things work underneath the hood, right? And as Lisa mentioned as well, right, this is designed to be a collaborative effort, not a one-off, not a solo effort. Really, it is really important to be able to do this as a team. And for teachers, if there are any teachers here, right, our class culture really matters. Ryan and his TAs really do a good job of creating a teamwork environment. Here's a snapshot for 1 year. Really want to point out the fact that Peter here, he started out as a student in 2017, which was the first CogWorks class. And now he's actually working at Lincoln Laboratory as an intern and is coming back and teaching this CogWorks class with Ryan. So you can see the students that we have here, they're all having a good time. They're all working together. This was our final event a couple of years ago, but it's just great to see the fact that the students are coming back. They're going further with their projects and they're going further with what they're learning here. I do want to point out that one of the things we've done, Lisa mentioned the blending learning model. We have online prerequisites, essentials of Python and NumPy that are important to be able to hit the ground running when we start the course in July. There's an introduction to machine learning. Those are kind of assignments to make sure that everybody understands is coming at the same starting point when the class starts. The online course uses a website called Python Like You Mean It. This is a site that Ryan and David Marshaka created specifically for this. It's kind of a Python boot camp for this cognitive assistance course. In the cognitive assistance course, CogWorks course, I'll probably just call it CogWorks, you'll see that there's 3 weeks of challenges and a capstone project. And I find the capstone project is really what's exciting about this. The individual challenges each week will make sure that the students understand what they're doing, what they're building, and see the results of what they've learned by building something. And the last week, in week 4, they're creating their own. They're picking a problem to solve. And that's pretty neat to see because we've seen them for everything from understanding sign language to looking at bullying and tweets to, I can't even remember all the different types of technologies that they've used to try and solve the different problems they've tried to solve with the technology. I'm not going to go through every week's challenge here. I'm just going to touch on the audio module, week 1, to give you a sense for how the week by week it works and how that's going to build into the final capstone project. So one thing that the students learn very early is that if you've got a signal, it can be data. And if you've got data, you can pattern match. That's really important. Everything can boil down to pattern, and machine learning boils down to pattern matching. 2D, 1D in case of a song, 2D in case of an image, multidimensional. So many data sets are multidimensional. But if you've got the data, you can start to do pattern matching. And if you can do pattern matching, then you can use that information to build something from. So, you know, if we talk about the central ethos of CogWorks, like we mentioned earlier, right? No mystery boxes. So how do we get from this WAV file, this audio file, to identifying a song? So the students will learn how the basic physics of how sound is recorded and digitized. And once it's digitized, what we can start to play with it, how we can start to do analysis on it. Because once you start to do the analysis, then you can start to do the pattern matching once you've done that analysis. So understanding the physics to understanding how it's digitized, and how we can do that analysis. That's all part of how we build CogWorks capstone projects. So at the end of the audio module, students will be identifying songs based on sound snippets, based on code that they wrote and trained, the machine learning and things that they trained. And to think about that, doing that is pretty neat because it's very powerful to be able to do that, write the algorithms and do that identification on your own. So the final capstone project, right? There are always teams. It's really important to emphasize here. We'll always have teams because some of our projects are strong enough, are difficult enough that you can't do it on your own. And that's by design. We want students to learn together. And students that are very passionate about building something together work well together as well. So there's a couple of examples of themes that students have picked in the past. The automatic study buddy. They're looking at a student's face. They're understanding when their eyes are starting to close. They're understanding what the facial expressions are. And if they match certain criteria, they'll play something upbeat music, right? The upbeat music that will wake up the student and get them motivated again. It's really neat to see the different types of projects that have come out. And at the end of our July program, all the student teams will showcase their events in a science fair style event. So that's really neat to see that the fact that they can make videos or talk about what they've actually done as part of their project. I mentioned the fact that we've got no black boxes. I'm going to touch on briefly for AI and ethics. I think this year, over the last couple of years, we've seen very strongly that AI, because of the training that goes involved, can be biased, right? And I think we feel very strongly when we're teaching AI and machine learning to students that they learn about what those biases are and how those biases creep into systems, right? And that's really what goes into the training material, what goes into the developing the algorithms to make those decisions automatically using machine learning. So it's important that the students understand what goes behind that so that they can understand those biases coming in and probably work to defeat them and work to make them better. So here's an example, right? AI and ethics, right? The language model will frequently only uses linear algebra, right? And word concurrence to complete analogies, right? A man is to doctor as a woman is to a nurse, right? That you can type into several different language models and you get that kind of answer. But that's not really a good model, is it? Right? So the language model that's purely mathematical, it needs a lot of data to train it, right? And it's that data that contains the bias, as I mentioned, not the algorithm. So that's where the challenges come in, how to create a algorithm that eliminates the biases without necessarily training it with a different data set. And so smart people doing the algorithm, doing the training will help defeat that, will help make better AI, better machine learning. So that's really what I want to talk about here as part of fundamentally in terms of AI and ethics and the BWSI courses. Because you are learning what goes into those, that you can help diagnose and combat those biases because you know what's happening. So the overall course, you saw this in a different form with Lisa, but what I want to show is that every year we're adding courses, every year we're adding more programs. And how do we do this, right? And I really want to emphasize the fact that from our little world at the Summer Institute, there's 200, 250, 300 people that we can help through our program every year, students that we can manage to get through our program. But that's just such a small number of students that we really want to try and expand. And by expanding, we're doing a number of different things. We're helping individual individual schools and student clubs create their own content, not create their own content, but to create their own program using our content. The Summer Institute program material, the curriculum, we offer free for use to schools and to nonprofits, and particularly to student clubs. You can go through the program online, work together as a team, and then possibly participate as part of our final event as well. We have several international teams from Korea, from Japan, from Mexico, and from Greece that all participate as part of our final event because they're working through the curriculum on their own in their schools, and then come to the final event to participate. We've had schools from, in particular, Madison Park and the Nelson High School here in Massachusetts participate, but it's an opportunity for you to work through the program on your own or as part of a local team, and then come to our final event and participate and be part of the Beaverworks experience. Another thing that we're also working on is working with professional organizations like the Society of Women Engineers, the National Society of Black Engineers, and the International Aeronautics Association, the AIAA. We're working with them to create their own challenges. And at that point, we'll have mentors from those organizations, professional people like staff at Lincoln Laboratory, who are willing to help mentor students work through a program and work through the challenge as a team. In that case, the Build a CubeSat program is something that's very exciting. Students are finding very exciting to build a prototype satellite. We haven't even gone into all the depth about all the different programs. The Build a CubeSat program is really exciting because you're literally building a satellite prototype that's 10 by 10 by 10 centimeters. You have to choose the science mission and the science and the sensors and the way that you're going to analyze the data to validate that mission and go through all the design steps for that satellite, for that prototype satellite. It's really neat and it's exciting to see those challenges taking off. But for some of you students who don't have access to mentors or to and want to participate in the July program, we're opening up enrollment in December. The online prerequisite courses are going to be open in February, but I want to put a QR code here for our application page of our website for teachers, parents, and guardians, and mentors. They can nominate students if they've got if any of you are here and you have a bunch of students who are interested, you can nominate them. And then from there, Lisa and I will take over and make sure that the students get the registration form. But for this year and for the students here, we're now offering a chance to self-register. The link is on this page through the QR code. Once you students register, and once it gets approved, and the approvals will not happen until January, you'll receive an email with information how to enroll not enroll, but just access the online courses. And you can start to work through those prerequisites. And all the registered students will receive the application for the summer program. The application for the summer program is fairly competitive. We have a lot of students who apply, and it's difficult to take everybody, even though Bob Shin would love to take everybody. We just cannot. But that enrollment decision doesn't happen until, I believe, May of this year. Lisa I think it's actually in April. The information's on the website. I'm just going to say that.
April 30th.
April 30th, okay. But the information's on the website. So let's see. we do have a video we want to play, but I think, I don't know, Lisa, do you have it on YouTube? I was not able to find it on YouTube.
I did not, because I thought you found it.
Yeah. So we're going to skip the video at the end and point you to our search for the Beaverworks Summer Institute on YouTube. And we have tons of videos there, both videos from students and videos about our final projects that I would encourage you to go ahead and watch because there's a lot of neat stuff there. It's a lot, the stuff that the students are working on are great. So I'm going to stop screen share. And then I think we're ready to take questions. Becca, are you helping us with the
Laura.
Laura, sorry.
Sorry. So I'll go ahead and I'm sorry if I say your name wrong. Iman, unmute and go ahead and ask your question.
Yeah. My question was, I know you already said this, but I didn't really hear. When do teachers have time to nominate until?
All the way through April, just about mid-April. Students can nominate, the teachers can nominate students all the way until April. When it gets to be April, it starts to be tough for students to be able to complete the prerequisite courses in time for the July program, but they can nominate.
Well, applications, yeah, applications for the summer program are due March 30th. So you can be nominated up to that point. It's just the odds of you being able to get in probably aren't that good. So I would say if you want a real shot at it, have your teacher nominate you by January. Okay.
And then when they nominate me, then I'll get the approval form or like the self-registration, I mean.
Yes, you'll get the self-registration, but you won't actually be approved until the end of January because the courses don't open until February 1.
Okay.
The prerequisites.
Okay, that makes sense. Thank you.
Another question we see in the chat is this program only for rising seniors, or can students who are about to enter college take part in it as well?
So the problem with we focus on rising seniors and younger students that are going into college, probably have other jobs, other things that they need to do. And because we're really looking to build the program for high school students and to create programs in local high schools, we generally don't accept we don't accept current seniors or students that are going to become freshmen in college. I think there are the other opportunities for rising college students to participate in, but not the Summer Institute.
And that's a question we're getting a lot in the chat is rising sophomores, rising juniors are also encouraged to wait until they're a rising senior, or can they go ahead and apply as well?
We encourage the younger students the rising sophomores, rising juniors to apply. As I mentioned, it's pretty competitive, but there's nothing to say that the experience they get working through the prerequisites isn't going to help them out in the future.
Yeah. We do accept very few rising sophomores and rising juniors, but it has happened. Yeah. So definitely apply.
If there's any other questions, you can go ahead and come off of mute. I'm going to go ahead and stop recording, but we will stay on for a few moments.
Sorry to interrupt, but what are the requirements for the application? Like, do we have to do any like school courses or like have a really high GPA?
No, not really. The prerequisites is what we use. Our online course is what we use to make sure everybody enters the course with an even playing field.
So there's like online courses for us?
Yes. Yes.
So like once we get accepted, we'll do the online courses, or do we do the online courses first, then we do the application?
So there's 3 steps: the nomination or the online course registration. There's the application, and then there's the acceptance, right? for the online course, it's important that you do those before you're accepted into the summer program. We accept everybody for the registration for the online course. There's no filter there at all, so that you can work through the online course. We use the